Hi folks, this is a tutorial for Lab 1. Let's get the show on the road. We're going to run a Quartus.
Next blank project.
New blank project. We're going to change to the C work directory. And then Lab 1. We're going to call this project Lab 1. Yes. Next. Now we're going to pick our chip, which is the Cyclone 2. And the name of the chip is EP2C 35F. EP2C EP2C and we don't have 484C6. If you look on the front of the chip, you'll see it. It's 672C6. So 672C6 right here. Next. All right, now we make a new blank BDF. And then we want to change the unused pin settings. Okay, now we're going to import the CSV file for the assignments of the pins. I have downloaded it to my desktop already. So now when you press Control-Shift-A, you will see the pin settings, the names, and the corresponding values. So thank me later. Now we're going to add a PLL to the design. So we'll go here. Actually, why don't we just go like this? PLL, mega functions, IO. It's called Alt PLL. There we go. It's not the Alt PLL though.
Yeah, it is. That's right.
Yeah? Okay. Here we go. VHDL. Next. Okay, so we're going to set this to 50 megahertz. And we're going to keep going here. We're going to take out the asynchronous reset and locked. Now, this is the sneaky part. We're going to set this thing to -3 nanoseconds. Okay. All done.
Take this off.
Which one?
The bottom one.
Why?
Just it adds time.
Oh, okay. Sure. Okay, so we have a nice PLL. Now we're going to create a nice Neos processor, a bunch of corresponding toys. Crunch, crunch, crunch. Okay, so we're going to call this SOPC. We're going to use VHDL. We know VHDL. We're going to add 3 Neos processors. Neos 2S. And then we're going to rename these guys to CPU 1, CPU 2, and CPU 3. Okay, now we're going to add some timers. Interval timer 1, interval timer 2, interval timer 3. Okay, so let's rename these bad boys. And we're going to put each one next to its own processor just for clarity. And then we're going to add a sysid component This allows the processors to identify themselves, and we have to rename it to sysid, no underscore 0. So we'll toss that guy up at the top. Now we need an SDRAM controller for the big memory, and we're going to go custom
Data width 16.
data width 16. The chip select
That's all fine. Take
is
that
all
off.
fine.
Done.
And finish. And we're also going to add an on-chip memory, not to FIFO. We're going to give this guy a nice 16K. Did I tell them 8K or 16K? 16K. Okay. So we're going to make this dual port access. And we're done. Okay, so now we've got to do some connections. We're going to take off all the instruction memory connections here. Then we're going to take off some more of these connections. Okay, now for these timers, each timer only needs to be connected to its processor. So we'll do that. And then timer. We've also got to add the reset vectors for everybody. We're going to set them all to SDRAM. So this guy also gets a nice SDRAM, but his offset is 0x1 with 5 zeros. And then here we've got the same thing, 0x1 with 5 zeros, but a nice 2 right here. And then for the third one, again SDRAM, and 0x2 and 0x2, but again the small offset. Okay, now we need a JTAG UART component. Okay,
Performance counter.
and a performance counter.
Mutex.
And the mutex. Okay, so the mutex and the performance counter are connected to everybody. The JTAG is just connected to the first CPU. Now we're going to keep going here with our craziness. So we've got to connect each timer to only its processor. So let's shrink these down a little bit, just so that we can see what we're doing. So the timer 1 for CPU 1 should have no connection for the two other processors. And the same goes for the other one, for timer 2, except that the timer should have priority 0. So what we want to do here is make sure that nobody interrupts other people with their timer. So the JTAG UART is for printing. We're going to make sure that only CPU 1 can print things. CPU 2 and 3 are only for calculation and not for communication. Okay, so now we're going to auto-assign base addresses. Oh look, no warnings. Life is beautiful. Okay, so because we have a nice SDRAM component here, we're going to have to put a PLL in, which we did. And now we're going to progress to generate. Save yes. And we'll be back with you in a second.